A box contains a total of 100 CDs that were manufactured on 2 machines. Of all of them, 60 were manufactured on machine 1, and of the total CDs, that's 100 CDs, 15 were defective. Of the 60 CDs manufactured on machine 1, 9 are defective. Let D be the event that a randomly selected CD is defective, and let A be the event that a randomly selected CD is manufactured on machine 1. Are the events A and D independent? So welcome to this video. It's JM from PyExcellence Tutorials, just like always. So now we're going to go direct into the solution of this problem. So I've already done part A of this solution, that is to write all the events the way they're supposed to be. So I've just copied event A and event D. Yeah. Event A is the fact that it's a CD selected is manufactured on machine 1. Event B is an event that a CD selected is manufactured on machine 2. I've also put event C, which is the event, so this word event, that a selected CD is good, and the last one is event D, that a selected CD is defective. So as you can see there, we don't have values for CD selected manufactured on machine 2, as well as event that a CD selected is actually good. So now let's try finding those. So they said the total number of CDs is 100. Of them, 60 were manufactured on machine 1, which means that those manufactured on machine 2 is 100 minus 60. That is giving us what? 40. So this one is 60. So 40 CDs manufactured on machine 2. So of all the CDs, 15 were defective, meaning that the CDs that were good were 100 minus 15, and that is 85. So 15 are defective. Now also let's look at event A and event B, that is manufactured on machine 1 and machine 2. So the CDs that were defective manufactured on machine 1, from the statement there is 9. So of the 60 CDs manufactured on machine 1, 9 are defective. So here we have 9 defective. So then how many defectives were there on machine 2? So the total number of defective CDs is 15. So we say 15 minus 9, giving us 6. So which means that 6 were the defective CDs manufactured on machine B. So if 9 were defective on machine A, how many were good on machine A, and all that? So to make these things simple, we can't just be talking here and there, let's just try to come up with a two-way classification table. So we're going to get a two-way classification table like that one. And then here we'll say, so there's event A, that is a CD is manufactured on machine 1. So we'll do that and that. Okay. So this is event A and this is event B, and then here we can have total. And then this is event C, this is event D, then also we can have total. So event A is a selected CD is manufactured on machine 1. So machine 1, the total is 60. Now we have event C and event D. So event C is that a CD that is selected is good. So how many were good for machine 1? So since 9 were defective on machine 1, so defective we have 9, that is D for machine 1. So the total number of CDs is 60. So 60 will be there. Also, the total number of CDs for machine 2 is 40. And 60 plus 40 gives us 100. The total number of good CDs is what? 85. The total number of defective CDs is what? 15. So to put what is here on B against D, that is what? 15 minus 9, giving us 6. Yeah. And then now, of those now manufactured, so since we have 9 and 60, so we have 60 minus 9, that is 51, meaning that the number of CDs that were good manufactured on machine 1 is 51. The number of good seeds manufactured on machine 2 is 40 minus 6, or 85 minus 15. So 40 minus 6 is 34. That's quite easy. But even 35 minus 51 is still going to give you 34. So we can have those numbers like that. So this is a two-way classification table, because you can add the total in here to give you 100. Also add in that way, it will still give you what? 100. So it's two-way. You go this way. Yeah. So now let's solve this problem. The question says, are events A and D independent? So events A and D can only be independent if probability of A given that there is a probability of D is the same as probability of A. This means that the probability of D has no influence on the probability of A. So whether event B happens or is there, it doesn't matter. It won't have any change in the probability of A. So that's how we are going to prove this. So let's find the probability of A. So we know that probability of A is equal to what? That is 60 over 100. Because we're just looking at the CDs that were manufactured on machine 1. So we cancel this. This gives us 0.6. That's the probability of A. Now, probability of A given D. Let me write this down here. So probability of A given D is equal to probability of A intersection D over probability of D. And this is what? So the probability of A given D, so A intersection D, so we're going to look for A intersection D. So A intersection D there is this A intersection D is 9. So we have 9 over, so that's just for A intersection D, over 100, and then divide by probability of D. So D is this whole thing here, which is 15 for defectives. So that is 15 over 100 as well. So this is 9 over 100 times 100 over 15. And these will cancel. Then we have 9 over 15, which is equal to what? So let's use 3 into 9 is going to give us 3 over 3 into 15 is giving us 5. So it's 3 over 5. So 3 divided by 5 is what? 3 divided by 5, that's 0.6. So it's still giving us 0.6. So we're going to say, since probability of A given D is the same as probability of A, then A and D are independent events. You end there. So that's how it's done. That means A and D are independent events, as long as it has worked. So you can also prove it in the other way. You can say probability of D given A, this should give us a probability of D, or probability of A given D should give us probability of A. Once this works, that means they're independent. Yes. So in fact, another formula is to say that probability of A, probability of A intersection D is equal to probability of A times probability of D. So this is another way we can work out independent events. So let's try that way if it's going to give us that. So A intersection D, the probability we have already found is 0.6. So what's the probability of A then? So the probability of A is 0.6 times the probability of B is 0.4. Probability of D, I mean, is 0.15. So we have probability of D is 0.15. Let me just create some space. Okay. So probability of D is equal to what? So since this is for defective and there are 15 defective, so it's 0.15. And then probability of A is equal to what? 60 over 100, which is 0.6. And then probability of A intersection D is equal to what? So we go to the intersection part, which is 9 over 100. So this is 9 over 100, which is 0.09. Now to show that these are independent, we are going to say probability of A intersection D is equal to probability of A times probability of D. And now A intersection D, we have already said is 0.09. Now this will be probability of A 0.15 times 0.6. So 0.15 times 0.6 is giving us the same 0.09. So which means that the events are independent. So 0.15 times 0.6 gives us 0.09. So the events are really independent. So this has been JM. I hope you enjoyed. Have a great day.